Okay, this is take one here. What we have here is a video of the hub scrub pump. Uh, this pump here is one of the ones that are labeled tested 25 to 30 psi, need 50 psi. We essentially have a setup here. You can see the full system. There's a bucket of water on the bottom, setting about 2.5 feet below the pump. So we're simulating sort of worst case scenario where the pump has to self prime up. Pulling up through, we have 1/4 inch hose right here into the suction of the pump, and we have reconnected a John Guest fitting here so that we can plug this this line into our test unit here, from which we are now coming out. We're coming out with the original hose that you sent and the full line. The full line goes down, and here are the nozzles. You can see are operating now both. Okay, so based on this system, we took the pump just as is, and the first thing we noticed is that the bypass screw was in all the way. Well, actually, we can leave it like that. The bypass screw was in all the way, and we were operating up here at about 80 psi with a very low flow rate. We'll simulate that again. Well, all we had to do was take the bypass screw out to this point where it's actually not even engaging anymore. This screw is almost completely taken out. We could even remove it. We could even remove the bypass. That means that the spring inside is not engaged whatsoever by the screw, but rather the back pressure from the nozzles are actually pushing back on that. And this pump, just as is giving us about, here's 40, and here's 60. It's giving us a little bit over 50 psi, and the flow rate is, this is a 0.5 GPM. See if you can see that. 0.5 GPM. The unit is operating at about little more than 0.4 GPM. So yes, both nozzles 0.4 GPM, 50 psi. The pump is operating where it should. Now, a couple of comments here is the pump running in complete bypass all the time is something that the pump will be able to withstand, but it's not the best case scenario. We probably could have, but this is a 1200 RPM motor. We could have done this job very well with a lower speed motor, but that's okay. This one will work, and as I see it here, yeah, this pump is not doing 25 to 30. There must be something else in the system that is either causing an airlock, possibly, that is not allowing the pump to fully engage, and that's why the pressure is not going up. Especially if you notice that the flow, because the flow, we see here, if you were operating at 25 to 30 psi, you should be getting about 0.54 to 0.5 GPM. So in the case of these pumps that you're showing are operating, this one's at 25, 25 to 30, 25 to 30. If you measure the flow rate, you should be getting 0.5 GPM at least, if not a little bit more. Now, if you're not getting that flow, if you're getting a lower flow rate and the lower pressure, there's something else in the system causing that, and most likely it could be air entrapment. It could be that the pump is sucking in air by somewhere on the inline. And we can see that it's not the discharge line at this point because we are using the same discharge line that you're using. You're using the same nozzles that you're using, and you can't quite tell what the spray pattern is here, but it looks like it's giving you full spray pattern, full atomization. It's a very fine, fairly fine atomization there. That's it. The pumps are working. The pumps are working okay, and as they are.